Okay, fine. So yesterday I think we looked at something about the data types, right? And then later we started with the operators. So yeah, any questions we have? Till now, whatever we have covered, you can ask any questions on this. Fine.
One
Yeah.
question.
Yeah.
Like what we have taught in like hex value and
Huh.
bit thing.
Hexadecimal system.
Yes.
Yeah.
So will it be like when we like in programming or developing anything?
Yeah.
Will it be useful like in every part step? Let's say we have completed this program and
हाँ.
यूज होगा या फिर ये सिर्फ बैकग्राउंड का नॉलेज के लिए है?
No, it depends like what kind of things you are going to do after this, right? Yeah, you will have applications where you may not need it, but yes, you will. There are applications if you go to certain places. Yes, for example, if you are going to work in IoT, right? Okay, you will be closer to the machine. You will be closer to the knowledge about bits and bytes. Okay, fine. So there, yes, it's going to be useful. So it depends of what kind of work you are going to do. Okay, fine. Even the byte order thing is, suppose uh, you normally have most of the time you have lot of ready-made things available, and so you don't even realize about the byte orders. Okay, but just think. Just give a very small example where byte order will be the knowledge that yes, we have a certain kind of a byte order that's useful. It applies at so many places like see we have image files. So image file would have a format, right? JPEG. Okay, so if you look at JPEG, how do I interpret the entire JPEG file? Suppose I have to work at the lower level, fine, and do some image manipulation, right? So you will be required to find out. Suppose you want to know what is the number of pixels wide and how much pixel in the height and width, both of them. So yes, in that format it is given at this offset, fine. It is given in 4 bytes. It's a 4-byte value at a given offset. It's not only that it is a 4-byte value at a given offset that you need to know. You need to know whether it is big endian or little endian also. Otherwise, you'll be reading the value wrong. You know the location. And realize, you should be knowing this. That's why having this knowledge is good. You may not always need it. Fine. Okay. Okay. Fine. Anyway, so this is the initial part where we will have overview of trying to cover most of the small things, and then we'll be doing our. We'll have a small kind of a something being developed in a step-by-step manner, right? We'll be able to create a server using networking, and ultimately at the end we'll have the networking and multi-threading. Okay, so you should be able to create some kind of a network-based server. Okay, and so that's what will how the entire thing is going to go. Okay. Okay, and yes, keep asking questions anytime you don't follow certain thing. You like ask immediately. Yes.
Whatever overview we have gone through on the internet or any book, let's say, like This was new.
Yeah, you'll find lot of things. You will find lot of things. May not find come across the text which covers that.
Maybe haven't focused enough because like operators and like
Okay.
what we have.
Operators, I think, yeah, most places you will find operators. These operators,
वो
yeah.
सब में ऐसा बताता है कि like syntax ऐसा है फिर ये होता है इतने टाइप के होते हैं पर ऐसा ऐसा नहीं बताया गया कि ये भी इम्पोर्टेंट चीज है तो ये और काफी यूनिक बिट्स एंड बाइट्स वाला यूनिक कोड वाला
Fine. Okay, fine, we'll proceed then. Okay, so last was okay, just a very quick look. So if you have more questions, you can have it. Yeah. Yeah. So we looked at this operators, right? Before that, it was about Unicode, the rules for identifiers. Okay. Okay. See, related to identifiers, there are still more things which are which you'll not come across those things in text, but yes, it will intrigue you. Oh, what is this like? Is this also there? Okay. I can show you one such thing. Okay. It's like you rarely come across this in any of the text. Okay. And some of the things not in the text and any form of text. Okay. See, we write our identifier, so use a variable name, right? And we know how the identifiers can be written. You can use any Unicode characters. Okay. Fine. Let's see. Valid identifier. Let's see. You can understand what is a valid identifier. That's fine. Okay. Now, okay, I'll use J so that we can demonstrate, and we can use Unicode escapes. Okay, because we can't see we don't have the appropriate font in our command line, so we won't be able to show with the help of fine. It may not appear fine properly here, so that's fine. We'll try to use Unicode escape and check the things. Okay, so yeah, what do we do? Int, give a variable name, some identifier you want. Yeah, let's say ABC equal to 45. And ABC is a identifier. Okay. I can use Unicode escape. It's see, what is it now? How many characters? There's not A, B, C, right? A, there is some character. B, there's that same character I have repeated, and then I'm saying C. Right? Is this an identifier? Yeah. You can think, oh, it's a valid identifier. Let me tell you, this is a soft hyphen. This character stands for a soft hyphen. Oh, there are so many characters, right? Okay. But the point here is, if I use this, okay, it's not a declaration, it's not a new variable. You may write this, or you may have that character. There are certain characters which we call as identifier ignorable characters. We have characters which are identifier ignorable, which means if you use them in an identifier, they'll just be ignored as if they are not there. Okay.
So like, what is the purpose? Like,
See, so if you put this in your code, the next guy is not going to understand what you have done. It's making it unreadable, right? Okay. There are things like, people would like to do code obfuscation, right? There's something called code obfuscation. So replace all variables which are meaningful names with something which is totally unmeaningful. Okay. Right? That's we call it as code obfuscation. So yeah, it's on those lines. You can just do certain things on those lines. Okay. Right. And the thing which is not mentioned, okay, in the specification is that even in the keyword, int is a keyword here, even in the keyword, I can use these identifier ignorable characters. And they would still be the same. So instead of int, I could have used that character here. This is one of the identifier ignorable characters. There are so many of them. Okay. And yes, when we look at the, I was mentioning that we have classes corresponding to the primitive types. And we have classes corresponding to the primitive types. And for the char related things, which is the class? Character. And the wrapper class is character. So anything related to char, the library is character, right? And the character class is my library. So you do have methods here by which you can test, is this character valid as a identifier starting character? Is it valid as a part of an identifier? You can test for any character value. You can give the int value for that also. Right? So it's like character dot is on the same lines. You have this to know whether it's an identifier ignorable. Yeah, is identifier ignorable? That's a method. So you have methods in these classes. Okay. So purpose of this class, wrapper class, it's not only about yes, that it holds a value of the primitive type, fine, but it is also a place for lot of useful methods for that primitive type and related to the primitive type. Okay. Yeah. Okay. Fine. So let's begin. Right. Okay. So I think yeah, we started with those operators, right?
yes.
Okay. I think you would know there is something called expressions. So what is an expression? Expression. And then we have types for the expression. What do we think is an expression? A very simple thing is, oh, anything which results in a value. Expressions are nothing but they have a value, right? Value will be of any of the types. Right? So expression simply which can have a value of a type. Oh, it can't be of type void, the lowercase v. Okay. And that's not a type for us. Okay. Fine. Okay. Because yeah, today I think we might need that information. Okay. Difference between expression and a statement. Yeah. Sorry.
Equation and expression.
Expression and not. I'm not talking equation.
No, both are similar.
No. Equation by mean equation. You mean doing an assignment?
No, no. It's a 1 plus 1, 2 plus 2.
It's an expression because it results in a value, right? Okay, fine. We have expressions, we have statements. Yes, we'll be moving towards statement also. Fine. But before going to statements, yes, we are looking at operators and arithmetic operators. Fine, we have seen. Then we had seen concatenation. So for concatenation, one thing which was understood, the information which is there is every data type is convertible to string. If you have a plus operator, any of the two operands is a string, then that plus will be used as a string concatenation. One operand is string, other is, if it is not a string, it will be converted to a string and string concatenation should take place. Okay, string conversion for null, and that's available. Okay, otherwise string conversion, if it is not a null, it's a reference type. Fine, in that case, how is the string conversion done? To string. Fine, we have the method called to string. Fine, equality again. So we had another method related to equality for reference type. If you want to know equality, fine, equals, fine, that double equal to for reference type means same object. Fine, it's not about equality. Okay. Okay, what else was there? Yeah. Fine. I think this string conversion thing, comparison. Okay, comparison operators. Fine. And you could have tried that NaN thing, right? Because that's quite unique thing, right? It's such a value where you compare NaN with itself and it won't be equal. Fine. So if A double equal to A is not true, then it is NaN. Okay, not a number. Logical operator, yeah, for each of those operators the expression is of which type. So if you have arithmetic, the expression will be of the type which is the higher of the two, and it should at least be a int. And you know this, int, minimum int. Okay, in string concatenation, the expression is a string, the result is a string expression. And for comparison, result is a Boolean expression. Fine. And in case of logical operators, the operands are also Boolean. And result is Boolean, but operands are also Boolean. Okay. Bitwise operators, operands will be int or long. Okay, int or long, and result will be accordingly. Fine. It depends on each of them, but it would be either a int or a long. Fine. Okay. Fine. In the shift operators, the second operand can be a int only. The number of bits to shift, that you can use long there and use int. Okay, fine. So yeah, now we can proceed with the assignment and casting thing. Okay, fine. What is the, okay, so what is assignment? Yeah, I was talking about, we I think trying to discuss expression and statement. What's the difference? Statements end in a semicolon. Fine, the entire thing has an end with a semicolon. Yeah, but what is the main thing about what's the difference between expression and statement then?
Expression will result in one value.
Fine. Expression is always a value, whereas a statement can be
In value or
without a value. It can be that void thing, okay, not resulting in anything. Okay, fine. So you will find things which are both expression and statements. Right? Okay. For example, the assignment. What is the assignment? What are the assignment statements we have? Which are the assignment operators rather? Oh, I'm saying using the word operator here, right? Assignment is a operator and assignment is a statement also. And it is both used as a expression as well as a statement. And for example, you might have come across this maybe int a equal to 5, int b equals maybe 7, and then you will say if a equals b. In C you might have done that, right? It won't be valid here. Okay, but what is this? It's an expression. Okay, but it can't be used in if, but someone could have done like this, right? Then you see this, what is this? It's an expression, right? It's an int expression, and then we are using the comparison for equality. Okay, fine. So understand, assignment is a expression also, and when we use assignment as a, it's a there as an operator, so you can use it as a, so fine. So we okay, most of the time, yes, we would have done like a equals b, fine, it's a statement, but this is also a value. Okay, a equal to b is a expression also, fine. Okay, so you can always do like this, a equal to b equal to c. Okay, of course c should have been declared earlier. Okay, equal to, and maybe 35, or you want to put 35 in all of them. Okay, fine. Now rules for assignment. We know supertype subtype relationship, right? So what is the rule for assignment? In assignment we have two operands, right? Left and right. Yeah, so what is the rule? Left operand is always going to be a variable. That's one thing. When left has to be a variable only, and it can't be an expression. The operand on the left cannot be a expression. It has to be a variable. It may be a declaration of a variable also, right? We do that, int a equal to 1, fine, in the same line. Okay, and for the right hand side, the second operand, right? It can be what kind of expression? Right hand side would be an expression again, right? In assignment, the right hand side is an expression. What kind of expression can it be? Something, how do you relate it with the type of the variable? Left is a variable, right? It has a type, right? So now we know supertype subtype things. So from that point of view, the right hand operand will be either the same type or a subtype. Fine, it cannot be a supertype. Fine. Fine, we know supertype subtype, bigger type, smaller type. You can think in that manner. Bigger type and a smaller type. Fine, or supertype subtype. Super is bigger. Okay, double is a supertype for long, yes, right? So if I have long and double, you cannot be assigning a double into a long variable, but other way around is fine, right? Fine. So every expression, see, Java we say is a strictly typed language, right? We say Java is a strictly typed language. So what do we understand by saying, oh, it's a strictly typed language?
Case sensitive.
Case sensitive is even most languages are case sensitive. Most programming languages strictly typed.
Space not allowed.
Huh?
Space not allowed. With
No. It has something to do with type, right? Data type.
yeah.
So when we say strictly typed, what does it mean?
Use the particular type data type.
No. At compile time, and at the time of compilation, right? The type of every expression is known. There is a type which can be derived by the compiler for every expression used in the program. And in your source code, any expression which you have written, the type for that must be determinable by the compiler. So at compile time, it's not executing. So it hasn't seen what are the, so each statement, look at it independently, and yes, the type has to be derivable. Okay, then you should be able to derive the type. Yeah.
Every variable should be declared first.
Okay. Yeah.
Like, that's how we can know the like it is a
Yeah.
type int float or anything.
So whatever the right hand side also, right? So in an assignment, if I'm looking at assignment, the right hand side, the type has to be known, right? Something which can be determined. Okay, so what kind of things you are using? So when we were discussing operators, I just mentioned about the type of the result of the expression, right? Every expression has a type which is known at compile time. At runtime, yet the type can be either the same or it can be a subtype of whatever is the type known to the compiler. See, for example, you have a variable called int a. Fine, we have a variable int a. So we have said, oh, a is of type int. Okay, but then what do you assign to this? You have assigned a byte value to it. Fine, somewhere you have assigned a equals b, where b is a byte. Okay, it's a subtype assignment wise. So it will, yes, the assignment will say, I see that it is either the same type or it is a subtype. So this assignment goes valid. Okay, but then anywhere else, if you are using a again as an on the right hand side, for the compiler, type of a is int, though it holds a byte value. Okay, you have a variable v of type vehicle. Type is vehicle. Fine. So you have a vehicle v equals, oh, what do I put in that vehicle? In the variable vehicle? Vehicle is a class, name of a class, yeah. So what are the vehicles? What are the subtype of a vehicle? Car, fine, bike, anything, right? Oh, there are so many of them, right? Okay, so in V, what can I put? What can I assign into V? Car. Okay, it's a subtype. Okay, fine. For the compiler, V is vehicle only. Okay, let's see what do we understand by this. I think with the int type, you might have already, okay, let me put the two things in parallel. So int, we have int a equals 5, and then we have, okay, I'll put semicolon also, and then we have byte b equals a. Oh, what does a have? A valid byte value. Hey, it's a byte value which I'm having. So if I say int byte b equals a, is it going to work or is it an error? What's the type for the right hand side? For compiler, what is the type? You've declared. every variable has a type which is declared. So a is always a type int. See, this will not depend on what you have assigned here. Maybe it is something like this.
So the size of A will be always int.
Here, the type for a is int. So wherever I'm using a for compiler, see, there is something called compiler. Okay, so the compilation, during the compilation process, right, should it be able to generate the source code for this or not? Sorry, the byte code for this. So will it be able to generate the byte code for this kind of a statement? So this, yes, it is 5 here, right? Let's come back to this. Okay, we have 5. It could be anything, right? So when you use byte b equals a, this will not compile. This a is of type int. That's it. The right hand expression is of type int. How do I change the type? Yeah, use.
Like yes, in bracket byte or
This is known as casting. Okay. Okay. Fine. And many times we'll say down casting. This is your down casting. Casting from a bigger type to a smaller type. And that's a down casting. And we will also have the other way around also. If you want, you can do that. But may not be useful for the primitive types. Right? But there will be cases where when we have the reference of the classes, interfaces, you may be doing upcasting also for certain reasons. Okay. When we look at the what is a class, we'll see that part. Okay. Fine. So normally we do a downcasting. Okay. So when we do a downcasting, it is 5. This is fine in this case, right? Okay. Okay. Now similarly, so this we have to use casting, right? But exactly same example. Let's consider vehicle and car as two classes. They are reference types. Okay. V equals. Okay. I'll use the keyword new and say, oh, I'm going to create a car. Car is a type of vehicle, and we understand it would be a subclass. Fine, assumption is there. Okay, here. Fine. So V is of type vehicle. Fine. And someone says, okay, let me say C equals. Can I assign V here? Can that be done? Super type, subtype. Right hand side has to be subtype. What is the right hand side? What is V? It's a vehicle type. So this assignment will not be valid. So exactly what you were doing with the primitive, exactly same thing being done here. Casting. Fine. Okay, now let me make a change here. Let me make this as something which is not a valid byte. Okay. Yeah, what happens here? Yeah, what will happen when I do the casting with primitives? See, one is compiler. Is this going to compile? Yes.
yes.
What we do with casting is we silence the compiler. Don't give me error here. I'm making this of type byte. And
It will give a warning.
okay, they have started giving warning later. Yeah, in newer versions, yes. That there is a lossy conversion.
Loss of information.
Lossy conversion, yes. And there is a conversion involved from int to byte. Okay. Okay. Anyway, so this is not an error. This is not an error for the compiler. You are silencing the compiler by this. See, for compiler, it's saying, okay, fine, this is a super type, you are casting to a subtype, okay, you are doing a downcasting, it's a valid idea. Okay, downcasting is a valid concept. You can't be casting a boolean to a int here. If there was a boolean and you say, I want to cast it as an int, no, because there's no relation of super type subtype between the boolean and the other primitives. All the other primitives, they have a hierarchy. So there is a conversion involved basically. Okay, you can say there is a conversion. What kind of conversions are involved? Upcasting, downcasting. Fine. So we say it's a there is, from a double, if you are going downwards, fine, we call it as a narrowing conversion. You are making it narrower. Fine. From a smaller type, you are making it bigger by using a cast. Okay, it's a widening conversion. So we have narrowing conversion, we have widening conversion. There's also mixed conversion involved with the primitives. Fine. For example, a byte or a short cast into a char, it will first be converted to a int. So it's a upcasting and then downcasting to char. You recollect that hierarchy. What was the hierarchy we had for the primitives? And double, float, then long, int, and below int there are two trees, right? Two branches. And one is char, other is short. Right? So between char and short, they don't have supertype subtype relationships. Between char and the byte, no supertype subtype relationship. But casting is allowed there. So when we do a casting, it will first convert to the common supertype, which is int, and then to the destination subtype. So there is a upcasting and then downcasting. Right? Upcasting to a int and then downcasting to the destination type. That's a mixed casting. Okay. Fine. Narrowing. It's conversion. The term used is conversion. Right? Narrowing conversion, widening conversion, and mixed conversion. The other conversion. When we say the term conversion has been used, like when we do a string concatenation, we call it as a string conversion. Everything is convertible to a string. So that's a string conversion. We'll see one more type of conversion also. Okay. There's something called boxing and unboxing conversions. So conversions, yes, that's about conversions basically. Okay. Fine, narrowing conversion, widening conversion, understood? Okay. Fine. For primitives, you have the mixed conversion as well. Anyway, so this one is fine. So what happens here? It will convert and there won't be any error. This will go ahead. What will be done is, it will, A is made up of 4 bytes, but you are saying, I just want 1 byte. So the least significant byte will be managed. Fine. First 3 bytes are cut off. Least significant byte, whatever the value remains in those bits, yes, that is what will be assigned to B. Okay, so let's do a similar kind of a thing with the reference type. Okay, let's see. So I'm not having a valid car. I want to keep a bike here. Okay, fine. So now, yes, what happens now? What about compilation? V type is vehicle. For compiler, he doesn't know what's happening. He's not running the code to know what was the previous statement. So what would we be having at runtime? It's not executing. Compiler is just going through the expressions. What is that type? Oh, that type is a vehicle type, right? V is a type vehicle. And you're saying, I want to do a downcasting. Okay, downcasting is allowed, right? Downcasting is valid. It's valid for the compiler now, but at runtime, can I do a cast? Can I convert that bike and use it like a car? Do you want to allow a bike to be used like a car?
Runtime it will give a problem.
So at runtime, this is a error coming at runtime. Okay, it will say class cast exception. That's the error it will give. So it's an error at runtime. For primitives, it's not an error. It will go ahead with the wrong result. Okay, right. When we talk about, I'm not going into the details, but what are the assignment operators? If I ask for the list of assignment operators, you know what are the assignment operators? Yes, this everyone knows, sir. This one, yeah. Which are the other assignment operators?
Plus equal.
Yeah, that's an assignment operator. Okay, fine. Sorry. Fine. So there are so many operators. Fine.
Exclamation and equal.
That's not a, because exclamation equal is for not equal.
Not equal.
Okay. Okay.
Divide.
Modulus equal to. Okay. Fine. So like this, there are few other operators also where it works. You can say and equal to. Yeah. Sorry. Okay. And for those logical, it can do that also. Okay, so we do have such some operator equal to, so those are all categorized as a assignment operators. And okay, so but the main difference is this, right? This is a class cast exception. Okay,
So basically, compiler is doing the type checking,
yes,
and it is making sure that it sticks to strongly typed.
so strongly typed means a compiler knows the type for everything, and then it is doing, yes, accordingly it's allowing or not allowing certain things. Okay, yeah, but
in this particular case,
yes,
the type checking happens at runtime.
actual type, because the type is this or a subtype. See, what can be there in V? It's either that class itself or a subtype. Okay, so which subtype? Okay, so when you are doing a cast, right? See, it was giving error if I don't put the cast, right? So what you are saying? Oh, I'm telling you it's going to be a cast. Now you are taking the, so when you do a cast, you are taking the telling the compiler, I know it's going to be a car. Use it like a car. Okay, cast is saying, I know it's going to be this.
But at runtime, when it goes, it says, okay,
Yeah.
it's not like that.
And so Java will not allow you to use an object kind created of a type to be used like some other type. And that cannot be done even by casting. So pointer thing is what? It's a dangerous thing. Pointer says, okay, oh, that's something. You the type could be anything. You have an object and you are having a variable of a different type and saying, okay, let me use it like that, because it's a pointer. You can point it and say, okay, that's my object. So it's not about. Fine, why would not like to call it pointer? Okay. Fine, variable are references. Fine. And it will not, so you can see it's so safe, like, right? So your object will not used, fine, this what is the object? Bike object, and will not be allowed to be used like anything which is not a bike. Okay, fine. See here, instead of bike, okay, I could be having sports car. Fine, then this is fine. But I think what I can do here is, okay, so we have this, create a copy, right? And then I'll change. Okay, so in this case, yeah, so it's a sports car, then what happens, right? You won't have this. Yeah. When compilation will go through, but at runtime that's going to happen. What about this one? I have a sports car. What is sports car? A type of car, right? It's a subtype. Okay. With this, what we are doing is using the sports car like simple car. Okay. You won't be using. See. Why we are saying okay, it's not being used here. See, with C, what can I do? C dot. What will I be allowed to use? The methods available for the class car. Type, that type. These are the operations you can have, right? What we use depends on the type. Right? See, operators for primitives. What are the operators? We are looking at the. Oh, these are the kind of operands we'll have, right? So if this is the operand, that's a operator available, right? Logical, it will work only with Boolean expression, Boolean type. Okay, so given a type, yes, you will have what are given a type, you should be getting a list of operations available for the type. Okay, so here I will be able to say, okay, you want to start, you want to put it in first gear, second gear, that's fine. Sports car allows you a sixth gear. Okay, so with this, yes, you won't be able to say use a sixth gear. Okay, you are just using it like a car, but that's valid for me. Right? And you don't put a sports car in the city area. Okay, you may be using it still, right? But it won't be used like a sports car then. It's just like the ordinary car. Okay.
Like in the IntelliJ or any
Yeah.
uh,
IDs. Yeah.
IDs,
Yeah.
we get like by dot operator, we get all the methods available.
That's according to the expression, because the expression is known, right? So this expression that C is of type car. Okay, so from that C is an expression. Okay, that variable also is an expression. So from that, you know, it gets a list that this is the type and that's a set of methods
So
available.
in that we get the list of methods.
Yes.
But while let's say in this text editor, if we have to code that same particular, how do we know that it is valid or?
Yeah, that you should be knowing. Anyway, so that's the utility of the IDs, and they can help you. Okay. But anyway, for most of the classes, right, when you define a class, the methods which are defined will be so natural that you will be able to remember them.
So there won't be any like textual reference that you should be like using this kind of method.
I'm not getting, sorry.
Like
Huh?
ऐसा कोई like रिटर्न नहीं होगा कि आपको like ये है तो ऐसा मेथड है, ऐसा कुछ नहीं, ये स्पेसिफिक आईडी और उसके हिसाब से होगा.
आईडी जो बोल रहे हैं ना, सेम थिंग, but whatever ID is giving, and you'll see that they're all very, the method names will be like this only, like what should be there. Fine. For example, if it is a date, then yes, what kind of method should be applicable to a date? Hmm?
Whoever has written that class and
Huh.
its method,
Yeah. Yeah. So it's
documentation also. So
yes, documentation. I think we have seen the documentation. We use Java doc.
Yes.
Documentation is there, so that's one option. But yes, you don't want to go through documentation. You should be able to remember if the method names are very natural. Right? Method name should be very meaningful.
If we have written that class and the method,
Yeah.
then we will remember intuitively. But if some someone else.
You are using someone else's class, right?
Then we have to rely on the documentation. Or if we use that library too frequently, then okay, we'll get the hang of it. Of course, ID is always this. So ID is great help.
Then the idea becomes clear now.
Yes.
Okay, so casting is upcasting, downcasting, but not okay. For primitives, that mixed casting is there, fine. But for reference, it's only upcasting or downcasting that we can do. We have one more place where a cast is used. It's used for conversion, which we call as a boxing and unboxing conversions. Okay, so cast is also used for boxing and unboxing conversions. You may have the type integer a equals, let it be a1. A is already there. Cast as int. Sorry, cast as integer. Between what is a type is int. Between the primitive type and its corresponding wrapper type, the conversion is possible. A wrapper object holds a value of the primitive type. A wrapper object, see why we call it as a wrapper? It's a wrapper because it is put inside the primitive value is inside the object. It's put in the object form. Okay, so we say this conversion is a boxing conversion. So this can be achieved with use of casting. So casting can be done like this. You can't do a cast of saying, okay, the type is long. Okay, that's a wrapper object. But you can't be saying, okay, let me have b1 equals cast into long a. This is int cannot be cast into the wrapper of a different type. The relation which we find, yesterday also I was showing this, the relation of supertype subtype which we find in the primitives doesn't exist in the wrapper types. Long is not assignable to an integer, or integer is not assignable to a long. Integer is not assignable to the long. Okay, they are not related.
Because it's not in the hierarchy.
Not in the hierarchy. Okay, and this boxing, we call this as a boxing, and this is boxing conversion. Okay, this is nothing but your, so this one is a boxing conversion. And one more thing here, I could have done like this also. It doesn't need that, fine, but this is still what we call as a boxing conversion. We call this as an automatic boxing conversion. So this auto boxing conversion, where you may be able to use a primitive like the corresponding wrapper or a wrapper. Oh, other way around is also there. We can also, so once this is done, I could have said int x equals a1 valid. Okay, so we have the auto boxing conversion and auto unboxing conversion. Or someone tries to use with a cast and says yes, So cast to int is valid. I'm showing the valid cast operations. Okay, and why this conversion, especially the boxing conversion, may be required with the help of cast in some cases, because we understand there is an automatic conversion. Okay, why this may be needed in some cases is like this. Most of the time you will find that wherever a primitive is usable, primitive is available, you may use it just like the corresponding wrapper type, or for the wrapper type you may use it like a int. They can be used interchangeably. This happens from Java 5. Okay, boxing, unboxing, automatic conversions available from Java 5. Okay, now let me show you why we need that first one. Okay, there will be places where you might need that first thing. Okay, because if I have int a, okay, we know a is a type int, primitive type. Okay, so you can't be doing a dot something. Dot is not available for primitive type. This results in a compilation error. Whereas if I have a1 plus b1, okay, where b1 is a again an integer, or maybe yeah, integer. Okay, it would do a automatic conversion. Oh, I'm using the wrapper just as if it's a primitive. See, plus is operator available for the primitives, not for the wrapper, but I am able to use it. Right? Or maybe plus 5 also. Okay. This is valid. Okay, but if someone says a dot something, it's not valid. Okay, there are methods, for example, a dot, okay, someone tries this, not valid. But if you do it with a1, valid. Okay, a1 dot toString is valid. Okay, string conversion for a object reference type. Okay, but a dot toString, so you know normally, yes, this automatic conversion means, oh, you should be able to use it like the corresponding wrapper type. Okay, unboxing conversion, this is unboxing, but this will not happen. This will be rejected by the compiler. In such cases, you should first do a cast to a integer, right? And then use the toString. So make this expression as integer, and on primitives you can't do a method invocation. Okay. When clear on conversion, boxing and unboxing. Okay. Right. So maybe when we start using the things, yeah, we'll be able to use these things also. Right? There'll be places where we'll be using this.
So before the Java 5,
yeah,
they were managing manually.
Yes.
Manually.
Okay, I'll tell you what exactly is happening when we do both conversions. Let's see. So if I use like this, if I'm saying integer a1 equals a, I would actually have been doing it like this. Prior to this, we would have said value of, which takes a as an int as a parameter. This is what it was. How a primitive was converted to a wrapper. This is how it was done. And this is exactly what happens if you are doing a conversion. Boxing conversion is done with the help of value of method. Okay, unboxing conversion is done with the help of, so int x equals, okay, and I'll say a1 dot int value. Unboxing conversion is nothing but this. Okay, unboxing conversion is sorry. Okay, fine. Now, okay. Now I'll take this further. This example where we have used vehicle and car. Okay, fine. I'll take that example further, and okay, we have that comparison with A also, right? Okay, we have that comparison with the, okay, fine. Our example for int was saying int. Okay, now my question here is, how do I avoid this kind of a error at runtime? How do I avoid the class cast exception? Yeah, okay. Let me copy it again here. Okay, how do we avoid class cast exception? When we know we get a class cast exception, how can we avoid this? So for that, yes, what we can do here is, we'll say we understand there is vehicle v equals, could be anything, and we don't know what it would be, but it would be something which is a subtype of vehicle. Okay, now I can do a check if v, okay, then what should I be doing? I would like to use v like a car. Maybe you might have declared a variable car c. Okay, fine. Or okay, yeah. So if it happens to be a car, see what is this instance of? We call it as a operator. Fine. Results in a Boolean expression. This is a giving us a Boolean value. Left hand side, some reference. Fine. It would be some reference expression. Right hand side, name of a reference type. Okay, name of a reference type. When it's not, it could, someone could be testing, is it an array, int array? Oh, that's also valid. Okay, so you can be testing for various kinds of reference type, any reference type. With the instance of, we check a reference, whether it's a particular reference type. Okay, so this is going to be executing at at runtime. At compile time, it just says, okay, this is a Boolean expression. Okay, so at runtime, if it happens to be a car, then only execute the body. So it's a Boolean expression, can be used in this, and then I will say, okay, car c equals cast into car v. Okay, and then use c dot. Fine, use this like a car. But before I start using it like a car, I'm doing a check whether it is a car. Only if it is a car, I'll start using it like a car. I'm not attempting it, right? So you can put it in a if statement. So checking whether it is of a particular type or not. Okay. Now, okay. Now I'll take another example here, and we'll do the instance of things. Okay, what happens in different cases. For that, let me take a different class hierarchy. May not be a correct one, but yes, I'll specify that we have a class date, and our date here has three things, three components: day, month, and year. Okay, and Let's assume also another class called time.
Hour, minute, and second.
So it has day, month, year, hour, minute, seconds. Okay, it has hour, minute, seconds also. Okay, it's managing addition. It's over and above the date. So it's date and the corresponding time. So we are going up to the time level. So there are a lot of cases where people will think this should be a superclass and subclass. When someone is defining time, he'll say, okay, I will extend from the date so that I get all those fields and create a subtype. And creating subtype of time as a subtype of date, it has more things. So assume this, fine. Let's not worry too much, but okay, this is supertype, this is a subtype. Okay, fine. Assuming date is supertype of time, okay, fine. Now just answer a few things. Okay, let's declare some variables, date d1 comma d2 and time t1 comma t2. Okay, I'm assuming these variables with their types. And now let's first check the assignments, which are the valid assignments. Okay, so find d1 equals new date. Okay, fine. d2 equals new time. t1 equals new date, and sorry, t2 equals new time. Which of these are valid and which is invalid?
T1 is valid, T2 is valid.
This is valid. Okay, yeah. What about this one?
Invalid.
See, which is supertype, which is subtype. First operand, second operand. Yeah, it doesn't seem natural, right? Because the example which I have taken, if I had used vehicle and car, it would have been very natural. Oh, you would have immediately said the correct thing.
Valid.
Yeah. This is valid. T1, time. Date, supertype. So can't be. This is invalid. Okay. And that anyway was valid. Okay. So now what we do is, because this is invalid, okay, and we'll comment this and change it to T1 equals null. Okay, let's make it T1 equals null then. And because it's not working, let's put null there. Okay, now, so assume these statements have been executed. Now we are doing a instance object. Okay, so I am putting the Boolean expressions d1 instance of date, okay, d1 instance of time, d2 instance of date, okay, fine, d2 instance of time, t1 instance of date, t1 instance of time, t2 instance of date, and t2 instance time. Yeah, which of these will result in true or false? They're valid expressions, they're Boolean expressions, but which is giving us true and which is giving us false, assuming those statements. Those were the assignments done. So at runtime, when it is executing d1, it comes across, what is d1 having? Object of type date, right? So is d1 instance of date? Right? So this is true. Okay, what about this one? D1 instance of time. Okay, just assume, replace time with car and date with vehicle, and then test the thing. You will immediately know what the answer is. And this is true. No, how is it true? It is false. Just assume what was assigned in D1 was vehicle. Okay, and I'm saying whether it is a car. Is that vehicle a car? No. Okay, or say car and sports car. Make it car and sports car. Because yeah, new vehicle may not be, it's not a very comfortable thing to say, just a new vehicle. We'll see the reason why it's not comfortable to say new vehicle.
Right, because when we say vehicle,
yeah,
that vehicle is a vehicle, can be anything. But when we specifically say car, it is a car.
Yeah. And car and sports car is good. And you could be creating just a car, or you could be creating a sports car. So just assume equal to new car has been done, and then you are saying, oh, is it a sports car? Clear? This is false. Yeah. What about this one? Okay. D2, and it's a subtype. Fine, so it's valid. This. Okay. We'll come across these two later because we set a null there. Okay. Fine. What about this? T2 instance of date. We got a time there. Checking for the super types. That's true. What about these two? What have we kept in T1? T1 has a null. So I'm saying, is it a time? Is it a date? Do we have a date object there? No. So this is it having a time object there? Is there a time object? There's no object. T1 doesn't have an object. So if you are testing instance of the for a null, that's always going to be false. It's not an instance of anything. There's no instance. Clear with the instance of thing? And we have all the cases, right? Okay. And it's always going to be between supertype subtypes that you can do an instance of. Okay. Fine. So next, let's see.
I didn't get the second one. D1 instance of time. Why is it false? Like time is a subclass of date.
Okay.
So why is it false?
Okay. I'll put it like this. D1 equals new car. Okay. And it's a car. Subtype is sports car.
False.
Okay. So I'm saying is D1 of that's the kind of test. See why there is a confusion when I'm using date and time, but as soon as I use car and sports car, confusion will go away. Why that happens? With car and sports car, you can see the relationship of is a. Sports car is a car. But if someone says time is a date, doesn't sound good. It's not natural, and that's why we are getting confused. Okay, it was more confusing. Fine, but it's to realize that yes, unless you have is a relation, we should not have done a subtyping. Okay, we shouldn't have created time as a subclass of date. That's not a good idea. Okay, but anyway, this was just to make you understand, realize, because you'll come across code and everything where people may have done such things. Okay, and you'll come across code because people do it like this. Oh, I'm having the same instance variables, I need them here. Oh, let me create it as a subclass, because you just learned about subclassing. Okay, try applying. It's not that way. Right? Only when you see a is a relation, then go for the subclassing. Right? We haven't yet seen how to create a subclass, and we haven't gone to the defining classes, but yes, that's just preparing you for that. Okay. Yeah.
Because in B1,
Uh-huh.
there is only date information.
Yes.
And let's say if we have a time, it has date and time information.
Okay.
So if we say that you take date and time and put it in days, loss of information. We are losing the time part. So that's why the instance of the wherever there is loss of information, the compiler will stop. Right? So that's why for the false part. That is one way of thinking about that.
Yeah, yeah. Okay. Okay. I think fine. Clear between super type, subtype only you will do the check. Okay. Now, yeah, some more operators are left out, but they are more like C language. Okay. We have the increment and decrement operators. Okay, fine, and that can be done in post and pre. So exactly like what happens in C language, with one small difference that in C language we will not find it for, it's only up to int, right? But here, yeah, it's available for all the numeric types. Okay, fine. So they would work for all numeric types. Okay. Primitive types, huh? Numeric primitive types. Yeah. Okay. Then, what other operators are there? Okay, there'll be so many operators which are just like available in C. Pointer operator is there. We don't have pointers. Fine, hyphen greater than, right? That was there in C language. But yeah, hyphen greater than is an operator in Java, but for a different reason. Okay, fine. So yes, what other operators? Fine, ampersand was used in C language, right? Star. Right? Whenever we use pointer, so pointer related things, no, we don't have them here. Okay, fine. I'm just making comparison with C language. Okay, but now we have few other things. Okay, I was mentioning about this operator. In Java, we have this, which is nothing but a lambda operator. This is from Java 8 onwards that we have a lambda operator. Okay, now what is the lambda operator for? Okay, for to understand that, yes, we'll have to understand that we have types which are functions, which are we have types which are functions. Example, someone says, oh, I want to have a type called int binary operator. What is an int binary operator? We understand binary operator. And for the int type, so what does it mean? What does a binary operator do? It has two inputs, which are the type int, and it will result in an int value. And it will result in a int value. Right? So these operators or functions, they are like a black box. Right? See, look at operators and functions as something like this, right? A simple black box, okay? And they will take some inputs. A function, how is a function taking inputs? With the help of parameter list. Okay, it's taking inputs. Okay, so if it's a binary operator is taking two inputs. They are of type int, and here it has code which takes these inputs, does some processing, but it has to result and return me a int value. Okay, it has to result and give me a int value. Okay, we do have this type called int binary operator. There is a type, there's a it's not a class, but there is one reference type. It's an interface. Basically there is some interface called int binary operator. Okay, and it has a method which takes two inputs and returns two integers and returns an int value. Okay, fine. And it says you want to have anything of the type int, so you can, now I'll write an expression here, int binary operator. Okay, let's say op1 equals, now what is this? It's a function. What is the int binary operator? A function which can take two integers as parameters. So I'll say, okay, it takes int a comma int b. See, when we define a function, we normally give a name. Here I'm not giving a name because it's just a function being defined which will be available from a variable called op1. It's a function available from op1, not giving it a name. Okay, and then so two inputs are taken like this, and then we use what we call as a lambda operator. After the lambda operator, we could be writing the body of the function. See, how do we define a function? I'm not giving we are not going to use the name of the function. They're saying I have a function which will take two inputs, write the body, write the code, and say return some integer value, return something. Okay, some expression which happens to be an integer type, int type. And this thing from here to here is a lambda expression. From here to here is a lambda expression, which is of type int binary operator, since int binary operator has declared a function which takes two integers and return type is a int. So this lambda, what is a lambda expression? It starts with a list of parameters. Fine, declare parameter. Okay, and it has a lambda operator followed by the function, the body of the function. So what exactly happens when someone does like this? It is nothing but definition of a function. This is nothing but a definition of a function, and we have a reference a variable called op1 which is having a reference to such a function. So this is an object which is a function object. op1 holds a function. op1 just has a function with it. Okay, how that function will be used? Fine. But the idea is this, right? So at one point op1 equal to this, another point op1 will have a different function object. We know a reference variable can change and refer to a different object, but it will always be of a type. The function is what type of function? A function which takes two integers and returns an integer. What is the implementation here? That can be different.
Function object.
Function object. We create an object of car, we create object of vehicle, we create object of a function also. What does a function have? It takes inputs, does some processing and returns a value. Or if the return type was void, oh, it's not returning a value, you might have such functions also. Fine. What type of function it represents? From that interface, known from the interface. Okay, so lambda operator is used in this place. There are actually more shortcuts to this also. There are few things available. Since we know on the left hand side, okay, it's a int binary operator. So what are the inputs that int binary operator takes? Integers. That function is taking integers, and therefore it's not mandatory to specify int a comma int b. I could have written it as a comma b also. This could have been written as a comma b. Don't declare the type. It's known from the type of the function which you are going to, because you are assigning to an int binary operator, the compiler will determine from there that yes, this is a type int, and the inputs taken are of type int. Okay. Another thing here is this would have a return statement at the end, at least. Fine. It would have a return statement to return an integer. Fine. So if we put a block if there are multiple statements, but if you don't have multiple statements, it's a single statement, don't use the braces. Just a, so it could have been a return statement, but we are not allowing a return statement here. Instead of writing the return statement, you can just use an expression. For example, someone can say AB, and I might say A plus B. Maybe I'm just doing a simple thing, A plus B. Yeah. So it is nothing but an expression. So if it's a single statement, you can write a just followed by only an expression, no braces. In which case it's like, oh, this is like saying, oh, return A plus B. The function implementation is return A plus B. And no explicit return here.
So this entire thing is called lambda expression.
This is a lambda expression. This is also a valid lambda expression for the type int binary operator. They will always have a type. They will always be fine. So this int binary operator is nothing but a name of an interface which contains a function. And when someone writes this here, many times you look at this code, right? And okay, because it's an assignment, I'll have to put a semicolon to end this expression. Fine, it becomes a fine. It's an assignment now. So op1 has this, right? In this execution of this statement, the function is not executed. Okay, many times you may get confused, right? Oh, this is not about executing the function. It's about creating the function. And it's about creating a function and not executing the function. The statement here doesn't execute what is the code written here. Many times, we have a tendency, we see the code and we think it's executing here. It's not executing here in this statement. This a plus b is not executed in this statement. If a plus b has to be executed, or that entire function has to be executed, it will have to be done by saying op1 dot and you need to pass two values. Okay, then it will execute. Then that function, you invoke that function. Oh, where is this apply isn't? Where does it come from? It comes from the int binary operator. Oh, that has this method. Int binary operator had that method, which was taking two inputs and returning an int. Apply as int is a method in int binary operator, which was saying I require two integers as parameters and it is return type is int. And so we have a lambda operator and we have something called a lambda expression. Fine, but fine. So don't confuse this with the execution. It's not execution, it's a creation of a function. The statement creates a function, execution is done by someone who will use that op1. And on op1, you have to call that. op1, it's a function of the type int binary operator. Okay, fine. Later, yes, we'll be looking into details of lambda expressions and we'll come across that. But this just to, we are looking at operators. So this, we have a lambda operator as well. Okay, fine. Let's look at the statements now. We can start with the statements or, yeah, you have questions now. Yeah. Any questions? Yeah. Some things might, yeah.
So we can, like C++, now in
Yeah.
Java, we can define our own operators anywhere we want.
Yes.
As in C++,
See, operators, I'll not say operators in that sense of like in C++, you could have, less than, that C out is using double less than. It's not about a shift, right? So it's overloading of operator. Those symbols are not operators. In Java, the user-defined operators are the methods. Methods are like operators only, right? You do a plus b, or you have a method called sum, which takes two integers. Fine. It's a binary, so therefore two integers. Fine. A ternary. That reminds. Oh, we have a ternary operator as well. Fine. Let's just quickly have a look at the ternary operator. Okay. Okay. Yeah, which is the ternary operator? We called it as a conditional operator. Yeah. Yeah, which is the ternary operator? Is a question mark colon. That means it has three operands, right? So what are the three operands? We have syntax wise, it's a Boolean expression. Okay, question mark. Then we have expression 1 colon and expression 2. Okay, fine. Let me just say expression 1 and expression 2. So this is nothing but a ternary operator, right? It has got three operands. First one is always a Boolean. Okay, Fine. Second and one, third, yes, they are related. How are they related? I've called it as expr1 and expression2. Okay. How are they related? Oh, they have a relationship or they don't have? Okay. Well, first question is, the entire thing is an expression. What is the type of the expression now? Okay. Let me take an example like this. I'll still put it like this. By example, what I mean is I'll just specify some type. So expression and question mark. Here is an int expression, colon, and here is a which one you want to take? Double expression. Okay. Right. So this is the type. I have just mentioned the types. And I'm not put some actual value. So the question is, what is the type of the whole expression? This is an expression, right? When we apply an operator, we get a value. What's the type of value? So we are only looking at the type currently and not what is the value which is there. So what's the type of the expression for this one? It depends on the those two expression types, right? So which one? It will be a double. Okay, fine. Fine, both it that, so it depends on the types of the two expressions there. Okay, now let me put it here. Okay, so because it will work even with, I'm only discussing the types here currently. Yeah, and here is where I say, oh, I have a car type, or okay, it's a vehicle type, colon, and this is the car type. Yeah, what's the type of the expression? Vehicle. Now I'll change it. Bike type and car type. Here, okay, type is yeah. So here, tell me, what's the type?
Any kind of conversion? No casting.
No, there's no casting. What we are not looking at execution, we are just trying to determine, like a compiler, what is the type the compiler expects? What will be the type for the compiler? For every expression, the type is known to the compiler. What will compiler understand as the type for this?
But can this expression can be standalone?
Yeah, yeah.
I can put this as a standalone expression.
So you may try to assign it to what type? See, it will be assignable to which type? Can I assign it to a bike?
No.
Can I assign it to a car?
No.
No.
Only vehicle.
Vehicle, that's it. So this is of type vehicle. Okay, now let me give a different one. Okay, so we have type, not a bike or this. Okay, you can keep one of them as maybe bike type, but the second one is a strange thing to do. Yeah, date type. One is a date, other is a bike. Uh-huh. Hmm. Object, yeah. Super type for everything, right? They don't have a common super type unless you reach the, it's a tree, right? We have all the type. At the top of all the types, for all the reference types, is a object type. Now, one more thing. From Java, we have that automatic boxing and unboxing conversions, right? So someone might have mixed it. Oh, there's a primitive type here, and there's a reference type here, and look totally unrelated, they'll become object. Right? For the primitive type, boxing conversion will take place, and that's how it will be used. Okay, we understand this ternary operator. Everyone knows how it is done. Fine. Depending on this, true or false, this one or this one, right? Expression 1 or expression 2 will be taken as the value for the expression. So value of expression is either expression 1 or expression 2 depending on the boolean. Okay, fine, clear? Okay, so unrelated, at the end, yes, we have object. Okay, see one thing, in older version prior to Java 4, 1.4 rather, okay, if this is what was like, it wasn't allowing these things. Okay, it would allow this one, but they don't have they had a super type subtype relation, then it was allowed. This was never allowed. 1.4, they said, okay, we'll identify the common super type and take it as the type. Okay, so bike and car was not valid prior to Java 4. So older code, yes.
Java 2 and Java 3, they used to do object everywhere object.
Yeah.
That was of course long time back, Java 2.
So 1.4, yes, this kind of thing had come. Change in the ternary operator was done.